Hello, so today's video is going to be on finding the area of a trapezium. This is a grade 4 topic and I've got another question generator which I'll explain at the end, but each of these questions is increasing in difficulty, and if you've got a question that looks similar to any of these sorts of questions, then that you can follow through the examples that I'm about to work through. So in order to do these sorts of questions, the things that you need to be able to do before you have a look at these are substitution into a formula, area of a simple kind of compound shape. So I've got an example here of a shape made up of a couple of rectangles. I also, the properties of a trapezium are really important. Rearranging formula, and for the fourth example that I'm going to, you need to be able to form and solve your own equations. So before we go on to using the formula, just a quick recap of what trapezium is. So there's three trapezia here. A trapezium will have one pair of parallel sides, and for each of those I've labeled them A and B. And then it will have a height. Now, even for this middle example, where's my mouse? There it is. Even for this middle example, even though the h is the distance at the bottom, if you imagine turning that round, so the a's at the bottom, b's at the top, and h goes up the side, that's a good way of thinking about it. The height that you use must be at a right angle to the parallel sides. We call that perpendicular. So for example, in the first question here, we do not use, you will not ever be using this slanted height to find the area. You need to work out, well, you need to use the height that is at a right angle or perpendicular to the one of the parallel sides. Okay, so for examples, let's start with this one here. You need to know the formula. The formula for the area of a trapezium is A plus B, divide that by 2, and then you multiply whatever you get to for that by your height. So the A and the B must be the parallel sides. So I always start by suggesting that we write A and B next to the parallel sides. Now, it doesn't matter which way round you do them. I could have said the 7mm was B, and I could have said the 12mm was A. It really doesn't matter. And then the height is going to be 3mm, because that is at a right angle to the parallel sides. Okay, so then it's just a case of substituting those values into this formula. So the area is going to be equal to whatever A is, which in this case that's 7, and then I'm going to add to that whatever B is, which in this case that's 12, and we divide that answer by 2, and then whatever we get to that, we're going to multiply it by the height, which is 3. So if I just tidy this up a little bit, 7 plus 12 gives you 19. Remember, a fraction is a division that we haven't yet completed, so that's going to mean divided by in a second. And then we multiply that by 3. So the area of this one is going to be 19 divided by 2. You have to do this bit first, just to tidy that bit up. 19 divided by 2 is going to give me 9.5. And then we can multiply that by 3. So the area equals 9.5 multiplied by 3 is going to give me 28.5. Now, because it's area, the space inside a shape, you must remember your units. So the units we're working with in the question were millimeters, but because it's area, that must be squared. So the answer to this question is 28.5 millimeters squared. Okay, next example, second example. This one is a compound shape. So you are asked to find the shaded area. So what this is actually is it's a big triangle, and that triangle has a smaller trapezium cut out of it. So the best way to answer this question is to work out the area of the triangle and then subtract the area of the trapezium that has been cut out of it. So I'm going to start by finding the area of a triangle. Now you need to remember the area of a triangle is equal to base times height divided by 2. If I scroll down a bit so you can see that. So why isn't that working? Okay, let's move it down. If I put that there, I can move that down there. Okay. So the area of a triangle is base times height divided by 2. So I need to know what this length at the bottom is of the triangle. So that's going to be this 5 plus this 1 plus this 5, or 11 kilometers. It's a big triangle. And then the height of this triangle, remember, just the same as with trapezium, the height needs to be at a right angle to the base. So this one here is 9. So to find the area of this triangle, I'm going to do 11 multiplied by 9 and then divide my answer by 2. So that tells me the area of the triangle is 99 divided by 2, or 49.5 kilometers squared. That's the area of the whole triangle if that trapezium hadn't been cut out of it. So now I'm going to find the area of the trapezium. I'm just going to move this over here. There we go. Now be careful when you're picking out your units here. Sorry, not your units, your measurements. That side is going to be 5 kilometers. And then this side is going to be 1 kilometer. And then the height of this trapezium is going to be 4 kilometers. Now, this on its own is just very similar to the last example that I did. So if I just put that there. So to find the area of this trapezium, I'm simply going to do my value for A. I should have labelled A and B. And we might as well label the height as well. Okay, so A is going to be 11. And we're going to add to that my B, which is 5. Always divide it by 2. And then we're going to multiply that by the height, which is 4. So now just tidying this up. The area is going to be 11 plus 5 is 16 divided by 2 times by 4. So the area is going to be 16 divided by 2 is 8, multiplied by 4. Therefore, the area of the trapezium is 32 kilometers squared. Okay, we are nearly there. Because remember, if I zoom out a bit so we can see everything, to find the shaded area, we want to do the area of the triangle, and we're going to take away, in this case, the area of the trapezium. So the area of the triangle we worked out was 49.5, and we're going to take away that 32. So 49.5, take away 32, 17.5, remember units, kilometers squared. That's it. So we've now found the shaded area of that shape. Okay, 2 more examples. You need to watch out for these questions. Sometimes you will be asked to work backwards. So what I mean by that is in this question you are told that the area is 7.5 millimeters squared, and you are not given one of the bits of information from the trapezium. In this case, that is one of the parallel sides, this bit here. So we need to use that information to find that missing value. So with these questions, you are always going to start with the formula for the area of a trapezium. Remember to label your 2 sides A and B. They must be the parallel sides, the sides that would never meet. We might as well label this as the H for height as well. Okay, now if we put these values in, I don't know what A is. That's X. That's what I'm trying to find. In fact, let's make that write that as an x. We are going to add to that my value for b, which I do know, that's 2. I'm going to divide my answer by 2, and then I'm going to multiply by the height, which in this case is 3. Now I know that when I do that, I would get the area, but we are told that the area, let's do this in a different, let's just do this in black. We are told that the area is 7.5 millimeters squared. So I can actually, instead of area, write 7.5. Now we just need to undo everything that's been done in the reverse order for BIDMAS. The first thing I would have done if I was working forwards, I would have started with x. I would have added 2. I would have then divided by 2. And then I would have multiplied by 3. And that would have given me the area. So because I want to work back the way, I need to divide both sides of this equation by 3 first. So I want to undo that bit there. Divide this side by 3, and divide this side by 3. That tells me that 2.5 is equal to x plus 2 divided by 2. I now want to undo the dividing by 2. So the inverse of dividing by 2 is multiplying by 2. So I'm going to multiply both sides of the equation by 2. That gives me 5 is equal to x plus the 2. And then finally, going back to this function machine at the start, to undo adding 2, I'm going to take 2, and that would tell me what my x value was. So from both sides of this equation, I'm now going to take away 2, and that tells me that 3 is equal to x, or x is equal to the 3. They're the same thing. So in this case, x was 3 millimeters. And you could always double check that by working forwards. So if my two sides were, I mean, that's our final answer, but you can check it by putting those values into this formula. So 3 plus 2 is 5. 5 divided by 2 is 2.5. 2.5 multiplied by the height, which is 3, gives you 7.5. So we know we've got that right. So x was 3 millimeters. Okay, last question is a little bit more tricky. And remember I said this one involves you forming and solving an equation. So here we are told the area, and we have the two parallel sides have been given to us in terms of algebra. And we're being asked to find out what that value of x is. So again, I'm going to label my two sides. I'm going to say this is A, I'm going to say this is B, and this is my H. So when I'm just going to put everything that I already know into this formula here. So I'm told that the area is 76. And I know that is equal to whatever my A value is. Now, in this case, A is just 6x. And then I'm going to add to that whatever my B value is. Well, in this case, that's 4x plus 9. We are going to divide that by 2. And then I'm going to multiply it by my height, which in this case is 8 kilometers. Now, just like last time, we want to rearrange this so that eventually I have the answer x equals something. So to do that, we first want to undo this timesing by 8 to both sides. Remember, whatever we do to one side of an equation, we have to do to the other. So I'm going to divide both sides of this equation by 8. Now, if I did 76 divided by 8, that gives me 9.5. Now I know that that is equal to 6x plus 4x plus 9 divided by 2. So the next thing I want to undo is this dividing by 2 bit. So I can times this side by 2, and I can times this side by 2. If I do that, on the left-hand side of the equation, 9.5 times 2 is going to give me 19. And then on the right-hand side, I'm just left with this 6x plus 4x plus 9. Now we're just going to tidy up everything on the right-hand side. So we're going to collect the like terms. Remember, you can only collect terms if they have an x in it. If they're the 6x plus 4x, we can put those together, but we can't put the plus 9 in because that doesn't have an x involved in it. You could have done this bit at the start. This bit, it doesn't matter when you do it. So 6x plus 4x gives you 10x. And then we've got this plus 9 bit on the end. So remember, the whole purpose of this is I want to find out what x is. So I want to have x equals something at the end. So the next thing that's stopping me from just having my x's on the right hand side is to take away 9 from both sides of this equation. And if I do that, I end up with 10 equals 10x. Or 10x equals 10. And change the sides around. Then I'm just going to divide both sides by the number in front of it, and that tells me that x is 1. And again, you could always check that by putting x is 1 into these two expressions for each of the lengths. So 6 times x would give me 6, 4 times x would give me 4, plus 9 is going to be 13. Then what I can do is I just work forwards using the formula. So 13 plus 6 is 19. 19 divided by 2 gives me 9.5. Multiply that by 8 gives me 76 kilometers squared. So we found out correctly that x equals 1. Okay, so what I've done, let's just go back to the question generator a second. There it is. So on here you have, we haven't done any with decimal lengths. You can make it more tricky for yourself by including decimals should you wish. That only applies to the first type of question though. When you open this file, you must click enable content at the top or enable macros, one of those two. Otherwise the buttons won't work. You can, if you wanted to hide a particular type of question, you can. You can practice individual types of questions. So if you just want to practice questions like the second example that I did, you can do that. If you want increasing difficulty, you can do that. And finally, once you've got the hang of all of them, it's a good idea just to practice a mixture of them, because that shows a really good understanding of the topic if you can kind of do all of them all mixed up. That's it. I hope it's useful. I shall upload a link to this file in the description so you can download it and get some practice. Thank you very much for watching. Bye.